Hey YouTube, Josh here with Tipsy Python, your casual guide to learning how to program with Python. Our goals for today's video are to introduce file manipulation using Python, and then secondly, create a little app that accepts some user input, writes it to a file, and then also retrieves it on demand. Today I'll be enjoying the world's #1 selling Irish whiskey, Jameson. I have had this one a handful of times, but I don't consider myself an expert about Irish whiskey by any means, so I am looking to expand my horizons a little bit. Let's just sip on this Jameson for a second and think about what we've been doing with Python. So far, we've been saving the state of our application, the data, and variables. And so far our app data has just been lists, strings, integers. All these Python objects are just stored in memory and RAM on your computer while Python is running. This is facilitated by your computer. When you start the Python shell or when you execute a Python program, it allocates a certain amount of heap space in memory to the running process. The good thing about this is that as our program is running, it can quickly read and write objects from memory. But the downside is that when the running process is terminated, that space in memory is cleared and given to the next running process that needs it. And that's why our calculator app didn't hold any of the historical inputs between sessions. Every time that we had closed the app and restart it, it would clear all the data because it was all ephemeral and in memory. And so a common task in programming is to interact with files on the hard drive, to persist the data to a file on the file system so that you can retrieve it later when it's needed. That's what we're going to be getting at today. Now I know that there's a lot of different files and encodings and types. We're going to keep it real simple and just use plain text files for today's lesson. So if you're so inclined, get your drinks ready. I always forget how sweet that is. Get your computer ready, get your Python shell ready. I'm getting into it. I'm going straight to Jupyter. When we're working with the file system, there's actually a really convenient module that's built into Python called OS. You can import it like this and then use some really simple functionality to check the file system, like os.get cwd, get current working directory, and it'll print the location that you're working in. And if I'm interested in seeing the files in this location, I can use os.lister. Simple enough so far, right? Now it's time to write our first file, and to do that I'm going to use another function out of the Python standard library. This one is called open. And it works just like this. I'm going to say file equals open, then a file name. It doesn't matter what it is, but I'm going to use tipsy.txt for our first file, followed by a comma and then a string that indicates the open mode. Because I'm writing a file, I'm using W here. Next I'm going to write some text to the file like this, file.write, and a string that I want written to the file. And finally, I already used open. To save the operation, I'm going to do the opposite and say file.close. To check on my results, I'm going to use os.lister again to see the files. And you'll see that indeed there is a file named tipsy.txt that has been written. Now I'm actually going to switch to my Windows File Explorer real quick so I can check on tipsy.txt. You'll see that it contains the output that I indicated inside of my code. Now that wasn't so bad, was it? To read a file, I'm basically going to follow the same process, but I'm going to open the file in read mode instead of write mode. For some extra material on the different types of modes supported by the open function, you can go straight to the Python documentation and take a look for yourself. Going back to Jupyter, let's demonstrate how to read a file. This time, file equals open, the name of the file, and read mode. We'll set a variable like content to hold the output. And just like last time when we're done, I'm going to close the file. And it's truly simple as that. Manipulating files with Python is very simple. Now there is one enhancement that I want to make while we're looking at this code with a fresh set of eyes. Every time you open the file, you perform your logic and then you close it. Now things can get a little dicey if you forget to close the file. That's why Python actually has a construct called context managers. A context manager makes our life super simple by performing an indented block of code in the context of an open resource like a file. I'm going to refactor the code that we just wrote to use a context manager. I'm just going to say with open the file name in the mode as file. I'm going to indent the block of code that I want performed in the context, and then all I have to do is dedent, and this manager will take care of the close for me. And the output here is the same as if we had just handled the open and close ourselves. Now the implementation here is really simple, but I don't want to underestimate how big of a deal this is. In a previous video, I had said that Python is a high-level programming language, and this is exactly what I mean. It abstracts away a lot of these basic tasks for us. There is no negotiating with the kernel to get file resources. We just have simple functions that just work, and it makes us productive as programmers. Oh man, this whiskey's starting to just work. But nothing in programming is without its gotchas. Let's revisit this piece of code and perform another action here. So I'm going to copy what we've already done. And let's say that I wanted 2 copies of the content. One called content and another one called content2. When I execute this, you'll see something funny. The file content was only printed one time, and I was kind of expecting it to happen twice. Upon further examination, we're going to see that the content2 variable is empty. Now, no need to be alarmed here. You haven't broken your computer yet. When you open a file for processing, there's actually a pointer inside the file that holds the position of where we are. And as you read a file, the pointer moves forward in position. Now, the thing about the pointer is that it only moves one way. Once it gets to the end of the file, it doesn't reset unless we explicitly tell it to. If that doesn't click conceptually yet, don't worry. Like most things in Python, the implementation is super easy. Let's add that into our code here. To reposition the pointer, all I have to do is file.seek, go to 0, the beginning of the file, and now I'm able to reread it from the beginning and get the content multiple times. Now, a lot of times when we apply programming to a file, we're actually working with a data file, and these typically come as structured data, simply meaning that we'll have some predefined format that we can expect the data in the file to resemble. To illustrate my point, and to get us hands-on working on this, I've staged a small file called whiskey.dsv inside of our working directory. In it, I have some whiskey names, followed by a pipe, and then the proof of the whiskey. Let's read in this data and start working on it. With open the file name whiskey_data.dsv, delimiter separated values. I'm going to open it in read mode as f, and my data equals f.read. And then I'm just going to print data. Now, just to get some practice with processing data, let's read through the lines and then print out only the whiskeys that are over 90 proof. Now, one approach here may be to say lines equals data.split by the new line character. So this should give us a list of the lines of data. And then to look at the ones that are only over 90 proof, we can examine them one line at a time. I'll say the whiskeys over 90 proof are, and let's start processing for line and lines. And for each of these, I'm not interested in the name just yet. I just want to check the proof. So for each line, I'm going to say parts equals line.split, this time splitting by the pipe character. This is going to give us a list named parts, has 2 index positions, the 0 index being the bourbon name, and then the 1 position being the proof. If parts1 is greater than 90, and guys, don't get fooled here, we read this file in as a string. It's still a string, so we don't want to compare, is the string greater than 90? We want to convert this to a float. If float parts index 1 is greater than 90, then we just need to print the same thing in the 0 index position. And there you go. Again, too easy with Python. Now, if any of this logic does not make sense, go to my last couple videos and review iterables, iteration, loops, and conditional statements, and you'll be brought right up to speed. Also, if you enjoy this type of content, remember to subscribe, because every time you do, an angel gets his share of the whiskey. Now you guys see the concept here. This was an extremely small data set. It took us longer to write this code than it would just to have done it ourselves, but if our data set was larger, if we had hundreds or thousands of lines to go through, we could have done it really quickly, really efficiently, not wasting our own time by coding it in Python. Now, let's script an application to practice. Sales tax calculator, you've been good, but it's time to say goodbye. Let's start a new application today. Let's make something that will keep track of my whiskey tasting notes. Now I'm thinking today we'll make another command line application. We'll prompt the user for one of 3 choices: write a new review, read reviews, or exit the app. If they select read a review, we'll prompt for the name of the whiskey, a rating, and some tasting notes, and then we'll save that to a file. And if we go the read review route, we'll read the data from the file and then format it and print it out to the screen. Now I always encourage you to code along, but if you just want to sit back, enjoy a little drink, and watch me do the work, I'll get you on this one. I'm going straight to my desktop and creating a new file here. I'm going to call this one review app.py. Now I'm going to open review app in Sublime Text for editing. And just to save us some time, I did write down some of the common code that we used in our last application. Talking through it real quickly, I have a while true loop. It prompts the user 3 things: write a review with W, read reviews with R, or exit. If the user selects exit, we set running to false and the loop terminates. And if the input wasn't what we expected, we simply print this line and prompt them again. Now let's code the read and write options. I'm going to start with write, and the first thing that I have to do is figure out where I'm going to store the file at. For a quick reference, I'm going to print the current working directory. I'm going to save and actually run my application to get this. I'm going to copy the working directory so that I can use it in my code. Data file equals our location. And being that this is Windows, I'm going to escape these backslashes. I don't want to recreate the file every time that this runs, so I could get a little tricky in here and create some logic to check if this file exists, but just to make things go fast, I'm going to create a file called data.dat, and in my code I'm just going to pin new lines to it. So my data file is now desktop/data.dat. Now these lines aren't really needed, they're just for development purposes. In the real app, I'm going to prompt the user for the 3 pieces of information that we need: the whiskey name, the rating, and the review notes. I'm just going to paste in a couple of other prompts that I have. We're going to get these 3 pieces of information from the user, and then we have to write them to the file. So with open my data file, I'm going to use append mode. I'm going to write this data to a long formatted string separated by pipes. And finally, I'll give a success message. Let's test this out to make sure it's working so far. I want to write a review. The whiskey name is Jim Beam. I give it a 6. Tasting notes are honey, oak, and funk. Looks like the review was saved fine. Let's just verify this in the data file. And that looks correct. We accepted some user input and wrote it to the data file. But it's not enough to just write it, we got to get it out too. Now before I actually code the read part, let's think through this for a second. So there may be multiple lines in the data file, and because I hard coded that new line character at the end, there's always going to be a blank line at the end of the file. So I'll have to account for that, but it's not going to be very difficult to go through the lines, split by the pipes, and then print it nicely for the users. Going back to my script, I'm going to print a blank line to start things off. Then I'm going to open my file in read mode and read the data out. I need to split the data by the new line character and then iterate through each line. Now I was expecting that line at the end to mess me up, but I'll do a simple check here. If length of the line is well, at least 2 pipes, then we'll continue. Split this line by the pipe character to get our individual data fields. I'm going to print a formatted string, whiskey, in the 0 index position of this list, followed by rating, followed by notes. And just for good measure, I'm going to polish things off with one more new line print. And as I was testing this functionality, I actually found that I missed a very important piece of logic here. I need to have a new line character separating the lines that I insert into the file. I have no idea how I'd make a mistake like that. I'm going to fix my app. I'm actually going to go back and clear this file, so we're going to start from scratch. Let me test it now. I'm going to write a review for Jim Beam. It's a 6. It was funky. I'm going to read reviews. My Jim Beam review is there. I'm going to write one more for Maker's Mark. It's an 8. I think it's charcoal and mint. Now reading reviews, I see that everything prints like I wanted it to now. And I'm actually going to validate the most important functionality. I'm going to close the app altogether, and if I hit read, everything was persisted. It was all read out of the file, and now we're saving state between sessions. Now I know there's a lot of room for enhancement in this app. Like I said, we could have a more deterministic way. Instead of hard coding a new line character at the end of every single line that we write, we could do some sort of check to only include it where it's needed. And we also need something in there to sanitize the data, because if the user hard codes a pipe, it's going to mess up our formatting, and our app will break when we try to read it. But that's outside the scope of this video, or I'm just shrugging responsibility for it. At any rate, let's talk about this Jameson a little. Although there's not an age statement on the bottle, on the website it says that it's aged for at least 4 years. And notably for a whiskey, it's triple distilled. I don't think Jameson's trying to be an oak-forward whiskey. It's going for smoothness, it's going for refinement, and it hits that very well. On the nose for Jameson, I get like honey and smoke, but not really like a peaty Scotch smoke, more like the barrel charcoal. And on the palate, it starts at the back of your tongue with like a grainy cereal note. Honey's there all the way through, and then it ends with like a little citrus orange peel kind of thing. And that was really smooth. Like, I'm of the camp that the term smoothness is overused when referring to liquor, but this one we have the absence of that alcohol burn as well as the viscosity of this liquor itself. It's very oily and very appealing to the palate. So all in all, Jameson doesn't blow me out of the water, but there's nothing offensive about this Irish whiskey. It's very good and very reasonably priced, and I look forward to trying some of their other offerings in my upcoming videos. Alright guys, that's all the content for today. If you enjoyed my video and you enjoy this kind of content, please consider subscribing to my channel. If you're interested in seeing the Jupyter notebook that I wrote up in the source code, I'm going to post a link for it below to my GitHub. And as always friends, until next time, Tipsy Python.